Suppose we have a number of charges, say Q1, Q2, Q3, and so on, up to say Qn. And we have to find the potential energy of the system of charges that have been configured as shown. Now, the potential energy due to the system of charges will actually be the work done to assemble all these charges. Will be the work done to assemble all the charges. So suppose we bring the first charge from infinity, that is very far away. If we bring the first charge from infinity, what is the work done to bring this charge from infinity? It is zero, because in the beginning there are no charges over here, so there is no repulsion, and so we also do not have to exert any force, and since we do not have to exert any force, hence the work done will be zero. So we can say that the work done to bring charge Q1 from infinity to its position is zero, because initially there are no charges and hence there will not be any restoring force against which work will be done. So the work done to assemble Q1 is zero, right? So we can say that W1, that is the work done to assemble Q1, is equal to zero. Now next is, what is the work done to bring Q2? Now, as we have seen from our earlier discussions, that work done to bring Q2 to its position when Q1 has already been brought in its position earlier is given by the expression what W say 2 1, that is the work done to bring Q2 when Q1 is already there. So W21, and that will be equal to W 2 1 will be equal to 1 by 4 pi epsilon naught Q1 Q2 by R12। ये हम लोग लास्ट क्लास में देखे हैं कि ऐसा होता है, जहां पे R12 क्या है, व्हाट इज R12? R12 is the distance between Q1 and Q2। ठीक है, ये है R12। Similarly, the work done to bring the charge Q3 at its place can be calculated in a similar manner. But for Q3, we have two charges already assembled over here. So we have to do work against the repulsive force of Q1, and we also have to do against the repulsive force of Q2. So the amount of work done to assemble Q3 will be equal to the sum of the work done to exert to exert force against the repulsive force of Q1, and also the work done to exert force against the repulsive force of Q2. So we can write it in this manner, that W31, that is when we are exerting force against the repulsive force of Q1, then the work done is equal to 1 by 4 pi epsilon naught Q1 Q3 by R13. Okay, where R13 is the distance between Q1 and Q3. So this is R13. Similarly, the work done to bring Q3 to its position against the repulsive force of Q2, that will be W32, which is equal to 1 by 4 pi epsilon naught Q2 Q3 divided by R23, where R23 is the distance between Q2 and Q3. Okay, so this can be continued. So then what is the total work done? That total work done will be the potential energy of the system. So the total work done W is equal to W1, that is the work done to assemble Q1, then W2 2 1, that is the work done to assemble Q2 in the presence of Q1, plus W3 1, that is the work done to assemble Q3 in the presence of Q1, plus W3 2, that is the work done to assemble Q3 in the presence of Q2, and similarly it will be W4 1, that is the work done to assemble charge Q4 in the presence of Q1 and also in the presence of Q2 and also in the presence of Q3 and so on. Okay. So now if we consider only these three charges, then the potential energy will be of the system will be what? It will be W is equal to from here to here. तो ये 1/4 पाई एप्सिलॉन नॉट ये हो गया कॉमन इन तीनों का, और ये तीनों जो है वो अंदर रहेगा ऐसे, प्लस ये वाला लास्ट. तो इस तरीके से ये हम लोग इसको ब्रैकेट फिर बंद कर सकते हैं. ये हो गया हमारा एक्सप्रेशन, फाइनल एक्सप्रेशन of potential energy due to these three system of charges.